Welcome class. Now today we will read about microscopy. Microscopy. What is the microscopy? Microscopy is a method to magnify the small object or to see small objects that we cannot be seen from our naked eyes. Microscopy is a method to see the object that we cannot see by our naked eyes. That is the microscopy. And in microscopy, two terms are there. One is the magnification. Magnification means how to these small particles. How can you enlarge the image of small particles? Like if somewhere is written 10x, it means is represented by the x. It means you can enlarge the image of the small particles 10 times. If somewhere 100x, it means you can enlarge the image 100 times. And somewhere 1 lakh, it means you enlarge the image 1 lakh times of the object of a small particles. Now one is their resolution. Resolution means if the two particle is there, the distance between them, is measured by is a resolution. Which microscope is measure the minimum distance, in which limit the minimum distance can measure by the particle, which can measure by the microscope. Some microscopy gives the image of these particles like this, some give the image of diffuse, or some microscopy gives the clear image of these two particles. This is that we can see by the difference between the distance between two particles. This distance we call d. This distance we call d. So now which machine or which microscope give the clear picture about this d, in which limit they can give the resolution. This called resolution. We call resolution. How much clarity a microscopy can give between two particles. Now resolutions, we have one formula for resolution is limitation of resolution is different for different machine. We said d equal to lambda is a wavelength into 0.61 upon n sin alpha. This n sin alpha is a numerical aperture. We will see. Now d is the limitation of resolution. D is the limitation of resolution proportional to resolution. If smaller the value of d, it means resolution of this machine is high because d is less. If a machine can measure the minimum distance between them at a limit, then we can say it is a resolution. Like this, your light can measure the 0.2 micrometer, where you can even less 0.9 micrometer. Electron microscopy you can see 0.5 nanometer, but optical microscopy you can see 0.2 micrometer. The distance between two particles is less than till 0.2 micrometer we can see by visible microscopy. If you want more clarity between them, you can measure by electron microscopy. This is the resolution. Now resolution depend on limitation of resolution. It means if this value, limitation value is less, your resolution will high. For limitation of resolution value less, we want lambda. We want lambda should be less. That's why we use visible lights, which wavelength is around 400 to 700 nanometer. The wavelength is 400 to 700 nanometer we can use in the visible light. And then the refractive index. If refractive index increase, then it will decrease. Refractive index. So we will use sometimes different refractive index value, substance like oil, emulsion to increase the refractive index value at the time of observation. Another is called aperture, numerical aperture. We call numerical aperture or angular aperture. Called angular aperture. The angular aperture means this is your image, this is your object, this is your image, this is your object. If this angle we call numerical aperture angle. This angle we call numerical aperture angle. We call this the distance between image and object and make an angle. This is the lens. You can measure this angle from here. This is the angle. How you can angle increase or decrease? You reduce the distance. If you reduce the distance, angle will increase. Then numerical aperture value also increase. This is the method you can reduce the angle. The numerical value aperture we want also very high. So these factors can affect the resolution of the system. The two terms are very important. How much you can enlarge and how much quality, how much the distance between two particles you can measure. So now we have a microscopy. Two type microscope is there. One is the optical or visible light microscopy, and one is your electron microscopy. Microscopy is optical microscopy or electron microscopy. In optical microscopy, we pass visible light. Here we pass electron beam. Here we pass visible light. Here the limit of magnification is 1000 into. Here is 1 lakh. Here is the magnification. The resolution is 0.2 micrometer. Here is 0.5 nanometer. This is the system for the optical microscopy and electron microscopy. Why we use electron microscopy? To get a good picture, to get a good quality of picture of an object, then we use electron beam microscopy. If we have a limited resolution we want, then we use optical microscopy. The image, colorful image you can get. Here you get only black and white. Only black and white image you can get. In polymer, where we use this morphology study of polymer surface, morphology. Polymer blend structure to study. Polymer composites. These have to be used in the polymer system, but mainly morphology we studied. Sometimes polymer with nanoparticles are there, then we have to study to see the dispersive and distribution system. Carbon black, rubber with carbon black. To check the distribution and dispersion of the carbon black, we use by the optical or electron microscopy. Generally people are using electron microscopy. Now we will see optical microscopy. In optical microscopy, we have We have one light source is there. We have one light source is there. We have a light source is there. This is the light source. This is the light source is there. Then we have a condenser lens. Then we have a condenser lens. This condenser lens condenses the light. This condenser lens condenses the light. Now we have a plate of glass plate where we put our sample is there. Where we put our sample is, we put our sample at the glass plate where we put our sample thin layer sample. We put or kept there some solid object we can put here. The light pass through these objects. Light pass through this object. Then we have a object lens is there. Then we have a object lens. Then we have a object lens is there. Then after object lens we have a eye lens is there. We have a eye lens is there. We have a eye lens is there. This is called eyepiece lens. Eye lens or eye piece lens is there. This is a system of optical microscopy. Optical microscopy. We have a light source. This is natural light, visible light. We can pass from this. Then the light is condensed by the condenser lens. Then condenser lens focus on our sample. Now sample light passes through the. We can get the image objective. The image of this we can get it from the objective lens. And after objective lens from our eyepiece lens, because here we can see from our eyes. Our eyes is there. Our eyes is there. So we can see from our eyes from here. Or eye we can see from your eyes the image is there. From eyes we can see from here. Now this lens is generally 10x. This lens is magnification is 10x. Eye lens magnification is generally 10x, and the objective lens may be 3 types is there: 10x, 45x and 1000x. The total magnification of this system, total magnification is equal to, if we take 100x, so 100 into 10 equal to 1000x. If we take 45 into 10, 45x, or will 10 into 10 equal to 100x. Because magnification is total multiplication of the objective lens, and eye lens is the system is there. Now this is the objective lens and condenser lens, and the image is made by the inverted. The image is made from the objective lens, and eyes lens are inverted virtual image. Note down this, friend, is important. We don't give too so much time on this. We have to understand what is the image we get is the inverted virtual image. This is the optical microscopy. This is the optical microscopy is there. So now this optical microscope is there. We will read about electron microscopy, transmission electron microscopy. Now here we use, instead of this source, we use as a tungsten. Here we use light source tungsten. Here we use tungsten. When you give the tungsten heat, they will generate electron. Now we will provide here 20 kilowatt electricity to an anode. This is the cathode, and electron have minus charge. Then we have to pass a single light. Then we have to pass a single image. What we will do? We do apply an anode. We apply an anode is a positive charge. When we pass the anode, then we have passed this. So now all the electrons are collect there. You can pass all the electrons are here. You will pass the electrons are here. Then the light pass through the conduction lens. Here instead of condenser lens, here is the electromagnetic lens. Here is the electromagnetic lenses. Where we are simple lenses, but here the electromagnetic lenses are there. Electromagnetic lenses are there. Then the light pass through this and put on the sample. Put on or sample is there. Put on the sample is there. They are electromagnetic lenses. Electromagnetic lenses are there, and this also a object. Electromagnetic lens is an objective lens, and this is our projection lens. This is our projection lens. This is our projection lens. There is no eye there. There you can measure by the computer system. Here you can measure by the computer system. The sample is there. Then the electron is passed from the surface. Electron is passed from the surface. Then electromagnetic waves, lenses observe this system. Observe this how they will measure electron system in this sample. Big particle size there, and small particle size are there. When you pass the electron, from here, then few electron is transmitted. Few have reflect by the big size of particles. So now the curve is, we will get like some the up and down of the transmission, the up and down value of the transmission, due to the electron, due to this big particle or electrocycle, then they will this curve, then the electromagnetic lens is there, then they will convert into a graphical representation of in the time image. They will convert into the time image system. They will convert into this time image into the system. Then they convert into the system. Now we have applied here is a vacuum. We applied here in vacuum to collect all the electrons in a single system. The electron is not go here and there. That's why we apply a vacuum. The electron system is there. This is the transmission electron microscopy, similar to our optical lens, but here we apply vacuum lens, and instead of objective or eye lens, we apply electromagnetic lenses is there. Here you measure this up and down transmission. That's why we call transmission electron microscopy. Now resolution is there. What till 10 lakh x or 0.5 nanometer. Until 0.5 nanometer you can measure this is a resolution, limit of resolution D, and this is for magnification for the transmission electron microscopy. Now we will go for scanning electron microscopy, how the process is there. Friends, this topic is we have to understand first how the working principle, nothing is important to us. Scanning electron microscopy is there. Now we have a thermonic cathode. We have a thermonic cathode, positive electronic charge. From there, if you give the heat or apply a electron voltage, then they will generate electron. If to collect this electron in a place, we apply a anode. Negative charge. Then all the electrons collect in a single line. Then we apply a condenser. The condenser light goes from the condenser is the electromagnetic lenses are there. They are condenser light. Here we apply scan coils. Scan coils is there. Then the light pass through again. This is called a scan coil. The scan coil is collect the material and again and scan the length of the electron or other things you can measure by this scan coil. After that, or sample here in the last. or sample is in last, then the electrons are fall on the surface. Electrons are falls in the surface, or it is can call control the direction of the system. Here the O system is there, then electron will generate, electron will generate, electron will generate. After this sample hit the sample and the electron will generate, but this electron is generated, we call secondary electron. Secondary electron. Secondary electron system is there. Now here is one chamber is there. Here is one chamber is there. Here is a resistor is there. It measure the system is with computer. It measure the secondary electron system. It measure the secondary electron detector. Here is a secondary electron detector, and convert this detector signal into a computer. Then we will get a magnificence image of the our object. Here is the light not transmitted. Here only the reflection. Here is only the reflection. Why we call secondary electron? Why we call primary electron? Because is our KLM system is there. Electron is there. So what they will, the electron come and attack on the system, and here they will give the, here they will generate a, here this electron is generated from here and will become a secondary electron. So lots of electron come and replace the this or electron nucleophile. Then system from replace this electron with the electron, then we will get a secondary electron, and the secondary electron detector is there. It measures the result and convert into the image. Here also we measure the magnification is the same as, and resolution is 0.5 nanometer. This is our scanning electron microscopy and transmission electron microscopy and optical microscopy, friend. But it measure the use in the, you have to remember morphology, structure, surface study. This mainly used in the polymer blend, polymer composite, polymer nanocarbon, elastomer is rubber with carbon blending. We see from this scanning, transmission and optical microscopy. So now friend, we have finished here because we don't require so much in the details for this. Thank you very much.